Hey everyone, this is Judy Warner with Altium's OnTrack podcast. Thanks again for joining. Today we have another great guest. Do you ever get tired of me saying that? Another great guest? Because we just have them every time. And we'll be talking with Bill Brooks today from Nordson Asymtek. And before we get started, I just wanted to remind you to please follow me on LinkedIn. On Twitter, I'm at Altium Judy, and Altium is on LinkedIn, Facebook, and Twitter. And also, if you'd rather watch this on video, we also have this on Altium's YouTube channel under videos, and you'll see all of our podcasts recorded there as well. So today we have Bill Brooks, who has he's been a great contributor to the industry, as well as being a very talented designer in his own right. So I thought you would enjoy learning about his long history in the craft of PCB design. So Bill, welcome. Thank you so much for joining us here. Bill comes from just up the freeway here from our office in La Jolla, so it's handy to get him over. So Bill, why don't you start talking about your professional history. I think you, like many printed circuit board designers, you were kind of set up to be in this industry, but you found your own path. So tell us a little bit about that.
Yeah, I guess when I was a kid, I didn't know where I was going to go.
Yeah, me neither.
My dad kind of introduced me to the electronics world. And right out of high school, well, actually, I was still in high school. My dad was working in the aerospace industry, and he decided to start his own printed circuit board shop. He looked around San Diego at the time, and there weren't a lot of shops to go get boards made. And he said, well, I can do this. And so he looked up the information. We started making printed circuit boards in the garage.
Good times. That was a long time ago where you could set up a board shop in your garage.
Yeah, today it'd be completely illegal.
Yeah, right?
I think the neighbors complained. He had set up, he created his own hydro squeegee. And he was using fusing oil, which was, I guess, peanut oil, And he bought this big 50-gallon drum of peanut oil, and he used a check valve, and he used air pressure to push it through a check valve and to spray it so he could put the boards down, get them hot after they had been coated with solder, and then squeegee them out as he pushed on the pedal on the floor, and it would just make this nice, beautiful, clean printed circuit board.
It's a handheld hot air leveling machine.
Yeah, it was very dangerous. In fact, I think he got burned a couple times messing with it.
I'm sure.
But the neighbors just loved it because they looked down at the corner of the cul-de-sac and they see this giant plume of black smoke coming out of the back of the house. They're going, what's he doing over there? But Dad was kind of an inventor, and he liked to invent things. So he didn't go out, and he was kind of a shade tree mechanic. He'd figure out how to get something done on a dime and do it himself. And I guess that same ingenuity was something I picked up. I figure out how to get things done. So
how did you end up going down the design path from building boards in the garage?
It was kind of convoluted. I thought I wanted to be an electronics tech and eventually electronics engineer. And I started down that path. I got a job with a company that was making television head-end equipment. The transmitter part of it, there was Channel 52, UHF subscription television, Oak Systems. And I started working as electronics tech for them, and I did a lot of work for them for, at least 2 years as a tech. And they were hiring in printed circuit board designers to do the layout work. And I had already learned how to do layout work with my dad's shop when I was younger, and I looked at that and I said, well, I can do that. How much do you make? And I think I was making like $7 an hour at the time, and they were making like 10 or 11. And I said, I could do that. And I told my boss, I said, I want to do that. I can do that. And they said, okay, we'll get you in the other department and start working in the drafting department. And so I got a $3 an hour raise, and
nice.
I started doing layout work instead. And it kind of set me down that path.
Right.
So that's how I got started anyway.
So, Bill, a lot of people that have been around a while, both you and I have been around a while, there's no college to learn what you've learned. So how did you pick up, you and I were discussing this earlier, you've done so many aspects, some RF, some electronics, some mechanical. How did you pick up all those skill sets sort of along the way?
That's kind of a, it's a long story really. My dad started me when he had his shop and gave me a printed circuit board to do as a way to teach me how to do layout.
Okay.
And we went to the TI handbook and found a circuit for an audio amplifier, 10-watt audio amplifier, and he said, you know, why don't you try to build that? And so I made a schematic. I took the schematic from it and I laid out the board, and we manufactured the board, and I bought the parts and I put them on the board and I soldered them and turned it on and talked through a microphone and it worked. And I went, yes, that's awesome. Yeah. It's so funny. I remember in 7th or 8th grade, we had a science fair in junior high. Mm-hmm. And everybody made their science project. They had a bunch of tables all set up, and my dad said, well, why don't you make an electronic metronome? You know, it has to do with music. And so I drew a schematic, and I put the whole thing up there, and I built the metronome, and I turned it on so it would go tick, tock, tick,
right.
tock, you know. And I thought that was amazing. It was really great. And one of my friends said, Bill, that was so cool how you did that, because I didn't have to do any of the work and I still got credit for it. And I said, well, it was a challenge, right? So I took it on, I put it up there, but I didn't win a darn thing. The guys who made the volcano won. They made the volcano that spews out all this stuff, and they got the prize. So people didn't appreciate what I was doing. I felt a little bit geeky and kind of out of the norm as I was growing up, and but I was fascinated with electronics. I was almost intimidated by it. My dad was a very good R&D guy, and he worked in the aerospace industry, and he actually worked on the Pioneer 10 space craft. Wow. And it traveled all the way past Jupiter, and it's outside our solar system, headed on for Aldebaran now, I think.
That's crazy.
So that's kind of a neat thing, and I think on one of his print circuit boards, if you find down in the little corner, you'll find his initials there. And
out in the outer reaches of space. Yeah.
Yeah. And I talked with Dr. Walker Filius. He was the principal on the project at UCSD. And after my dad passed away, and he sent me back an email, and he said, you know, someday these little green men out there are going to find that and wonder, what does that mean? Why did they put that there? You know,
That's
it's just
funny.
and a lot of people did that back in those days. We used to be so proud of your artwork, you'd want to sign it, right?
Right.
And we did that. So
that's funny.
Yeah.
So I have to say, I think that was probably a really invaluable experience for you, very young, to put together that design affected manufacturing, affected assembly, affected performance. Like at a very young age, you saw that whole overarching process, sort of on a small scale, but still.
Right.
And not everybody gets that experience,
to do that.
Even today.
Few designers have ever been. Ever been in a shop and actually made a print circuit board. A lot of them are dealing with the drafting side of it. They don't see the whole process.
Right. And it makes such a difference to the decisions you make as a designer.
Absolutely.
Right? And so I can see how that sort of set you on a path to be a little bit more globally minded about the whole, soup to nuts, kind of from design to reliability, right? Or how something is actually functioning.
It has a lot to do with curiosity. It's funny, I've been listening to a book about Leonardo da Vinci. And one thing that was amazing about him is he had this insatiable curiosity to almost distraction. I mean, he would look at things and go, why does it work that way? And he'd set himself a task to figure it out. And he didn't have a college or someplace to go learn those things. He had to do it himself.
Right.
I've done a lot of the same kind of things in my life.
Right.
I get fascinated with something and I go, well, I can figure that out. I'll go figure it out. All it takes is being brave enough to try and not being afraid to fail.
Right.
Failure is just an opportunity to learn more.
Right.
So I think Edison once said, he did like hundreds of different ways to try to do a light bulb, and he says, well, now I know 100 different ways not to make a light bulb. It's okay.
Right.
I'll still find one.
You only need one way to know how to do it, right?
Right. But those skills and the curiosity drove me into expanding my knowledge base, getting into printed circuit boards. I wanted to learn how to take the thing I knew how to make and turn it into something that was a product.
Right.
And I wanted to find out how to make that product appealing to somebody so that it made them happy with the product and not unhappy with it.
Right.
And that kind of dovetails with what we were talking about before. We have, as designers, we're kind of the glue to the whole design process. We may not come up with the initial idea that needs to be created, but we take that idea and we turn it into reality.
Right.
And we not only have to turn it into reality so that it's electrically functional, but it can be manufactured in a reasonable way that's not super expensive, that's reliable, that survives harsh environments or abuse. It has to be testable, so you got to provide for test points and things of that nature. There's a whole bunch of stakeholders involved, people who are, their job is keyed on being able to take what I create and turn it into a product that they can actually sell.
Right.
The marketing people have to make sure that the product meets the customer's needs. I have to be aware of that when I'm designing it, so I don't design in some function that makes it fail there. Right. I have to be aware of those things. So the designer, they're kind of the key glue to the whole group. And
but
people
I
don't realize
find that very refreshing, and I think most professional designers, from our early days of making a simple 2-layer board, say, it's so much more complex now. So we tend to head down into our specialty, right? Mm-hmm. And I think, as you have said, some engineers, designers have never been inside of a board shop.
Right.
And
it gives you myopia. You can only see just your part of the whole process.
And I can understand that because, I don't say that from a critical perspective. It's a very complex process. We're time constrained, we're resource constrained, so it's hard to put your head up for a moment. So you just named some of the stakeholders. So I would say fabrication for sure, assembly,
yes,
testing. You mentioned a marketing department, probably managers too, right? For cost.
Managers all have cost and time constraints.
Right.
They have time to market that they have to be worried about. The engineers, of course, typically are going to be concerned about can they get the parts? Are the parts available? Are they going to be end-of-life parts?
Right. That's a whole fun bag of goodness there.
The hardest part for some designers is they'll get the board 90% done, and then engineer comes back and goes, I can't get that part anymore. I need to put a different part in, and that's bigger than the one I gave you before. And so you got to go back and fix the circuit so you can fit that bigger part in there and make it work, and it gets quite challenging.
Yeah. So when do you recommend to sort of get those stakeholders on board and collaborating?
That's a great question, and it's funny if you go through the IPC, I think it's 2221 standard. It's the very almost first paragraph in the thing. It says, make sure you have a design review up front first before the design begins. Why do they say that? Those people all are going to bring their expertise and their wants and desires and their concerns to that meeting. They're going to be a part of that and give that information to the designer who really is the only person who has control over what it ends up being.
Right.
the creator.
Right.
They're the creator. They take all the information and they create something that can be built, tested, cost-effective, survive, functional, not have EMI problems, EMC problems. It has to pass safety agency requirements like TUV and UL,
Yeah.
or stand somebody handling it and giving it an ESD shock, thousands of volts.
Yep.
How's it going to survive that?
Yeah.
We do high pot testing. There's a lot of work that goes into making a board that just is not just connect the dots.
Right. So you're now working with Nordson Asymtek, which makes assembly equipment, correct? Or is there more than that?
Their key thing is, or the company I work for, they're making robotic equipment.
Okay.
The equipment allows manufacturers to do high-speed manufacturing very reliably, and typically they're dispensing fluids. They have a few divisions that do board inspection. They have one that does plasma cleaning. Mm-hmm. It's very common. I think it's Mark, I think is the name of it, something like that. Mm-hmm. But primarily we focus on fluid dispensing. Got lots of patents on fluid dynamics, how to dispense a dot of material that's the exact amount of the material and the right viscosity, the right mix of materials, and at the right place at the right time.
Right.
Very, very challenging
Very
stuff.
precise.
And we've come out with some really high-tech equipment that are making our customers real happy. So
That's great. Yeah. So when you do on a practical, where the rubber meets the road stuff, when you embark on a new design, do you get the stakeholders together? I mean, how do you do that?
We get a large number of them involved. We have a purchasing department that cares about who our primary suppliers are. Mm-hmm. They review them. We go qualify them, make sure that they're going to be able to supply what we want, when we want it, at the price we want it. We do a lot of in-house. What do you say? We use third-party vendors to make the boards, assemble the boards, test them. We put everything together in-house. You call us a system integrator kind of thing.
Yeah, right.
And I guess that's one way to refer it.
Right.
So the final assembly stuff all happens in the factory, and then we ship overseas and here in the United States and Europe. And
so you used a term which I've heard before, and just tell me what it means to you. Is the term concurrent engineering?
I was introduced to that a while back, and to me it was confusing at first. Of course, I've been in the industry a long time, and there used to be a model where engineering would be a little black box. And inside, all the engineers did all their stuff in there, and it was black magic, and they got it all done, and then they went pop, and they threw it over the fence to said, okay, you guys figured out how to make it. And that's as far as they went. The engineers were done. Okay, I'm working on my next thing. Have fun. And the manufacturing engineers got it and go, oh my God, how are we going to build this thing? And they almost had to re-engineer it to make it producible.
Right.
So that model was going along for quite a long time here in the United States before they started analyzing what the Japanese were doing and looking at their manufacturing process. And it was very organized, and they introduced just-in-time, which
I remember
has
all that.
affected the whole supplier chain.
It sure has.
But partnering with other companies to be able to be successful has become a big deal, and they can reduce the number of staff that they need to do what they need to do. Mm-hmm. They can have highly qualified people doing what they need to do. They don't need masses of people, and then they can subcontract things out, get them delivered on time, put them together, and get them out the door, and they're very, very good at it.
Right.
Concurrent engineering means thinking about everything up front, not just
you're part of
putting it in a black box and playing around with it until you're happy and then flipping it out and saying, you guys figure out how to build it. You want to bring the people that are stakeholders in up front.
Right.
And then together you move as a group, and the people involved in the engineering part of it have to understand those people's jobs because they're their customers.
Right.
They're the ones that are going to use what they create.
Right.
So we spend more time up front to make sure that they don't have to work harder, that they don't have to redo it, that we don't waste money and time out there with failures and have to come back and make changes and send it back out and say, oh, how about this one? No, that's not good enough. We got to do it again. Oh, how about that one? No, that's not good either.
Yeah.
So you educate the people that have control of it.
Right.
They put the intelligence into it to take care of them.
Right.
And everything goes smoothly. And we make a lot more product, a lot less expensive, and it's right the first time.
You and I were swapping some little statements, right? The one I remember you say, I don't remember who you cited. The hurrier I go.
That was my dad.
That was your dad?
Yeah.
The hurrier I go, he says.
The behinder I get.
The behinder I
get. And that's so true. It's funny if you have this, I'm the only important person in the world, and what I'm doing is the most important thing. And I don't care what anybody else thinks or wants to do. You can create something. In fact, I've seen some amazing sculpture of components that were soldered together in the most amazing ways, and it was an electrical circuit. It worked.
Functioned.
Yeah, but if you touched it, it would fail.
Right.
If you moved it, it would fail.
Right.
It wasn't built. It was just to see what would happen to the electrons when they get moved around that way.
Right.
So people, and there's a desire, typically, management has traditionally figured, well, if you whip the horses harder, make them go faster, you'll get there sooner.
Yeah. I have seen that, by the way, being a board manufacturer and selling to and working with designers. The constraints are brutal sometimes. So,
They can be.
And it's like, well, if you want me to put out good work, well, you need to give me a little bit more margin, right? And so I think, to your point, is you had also said that it's really a myth, the idea of a quick and dirty prototype.
Yeah,
right. It really is.
It's kind of a myth. I've worked in environments where there was a philosophy that said, we can be faster if we just slap something together and we go build it and we bring it back and see what it does. I think the people that had that idea probably didn't have any simulation tools. They didn't have any way to predict how it was going to behave.
Right.
So they would make one and go try it, and then they'd find out how it didn't work and make another adjustment.
Right.
So I remember working on a board that it had 17 or 18 different iterations of them trying different things.
That's so expensive and such a time suck.
Very expensive. And it takes a lot of patience. You just kind of have to work with them and keep going and keep going. But we win when you get a management group who, I happen to work for one, it's very, very smart people. They'd like to do it right the first time. So they spend the extra time up front, they do the research, they analyze what's going on, and then they go build it.
Right.
And when they build it and bring it in, we're like 98% there most of the time. Very few times we might maybe get one or two little blue wires and we're good to go. And take a few changes, boom, so by Rev B, you're out the door. Well, that's a good thing.
And the
CAD tools help us do that too, by the way.
Yeah, well, and that's a really insightful management team, I think, to know that if you take the discipline and time to do it up front, it really saves you so much on the back end in regards to time, money, resources. I always like John Wooden's quote. He used to say, be quick but don't hurry, right? It's the same thing, like be nimble and quick. Like we don't want you dragging your feet, but don't be hasty.
I think part of it is just having a good work ethic. The self-discipline to say, when I'm here, I'm going to focus on this. I'm going to get it done. And I'm not going to let, Joe come over and talk to me for a half hour about the thing he was doing up on the mountains last weekend, or, stop and shoot, with people at the water cooler or whatever, I'm going to stay focused on it. And when I'm not here, then I'm doing other things. But when I'm here, I'm focused. And I think that the managers, they should analyze their people and see what kind of people they have and try to work with them to get them to have that work ethic.
Right.
We've got lots of distractions in our world. Plenty of them, things that can take us all over the place. So
it's true.
It's just a personal discipline, I think.
So we talked about, in those cases, so I'm thinking about the people that are designers that are listening to us that may not have such an insightful management team as the one you work with, and I'm sure you've worked for other less insightful management teams. How
got a lot of years of experience.
Right. So how do you recommend that you kind of tactfully and professionally push back to say, I need 5 more minutes, to get this right? And if,
well,
how do you do that?
To frame it as pushback is probably not politically nice.
Okay.
But it's a communication. I think one of the things that you don't do is you don't go off into a dark room somewhere and then pop out with a design later on and they're going, what's happening?
Right.
So you have to have open lines of communication with your team. And our environment, we use the, I can't think of the name of it right now.
Like a project management?
Well, I'm thinking SVN. We use SVN as a way to load our projects into a common repository. And then the other engineers that are working can download that and refresh it or make it current. So the master is in the SVN file. So I'm working on basically a copy that I refresh every time I do some work.
I see.
And I do that regularly. I don't wait very long, and I'm refreshing it. I do it many times an hour sometimes. Sometimes I'll maybe go for a couple hours and then I'll refresh it.
Right.
But it's mostly based on how much change I've made to it.
Right.
The idea is to keep it current and keep the lines of communication with the other people concurrent so that they're aware of what's going on. If they're busy working on the schematic while I'm working on the board, we can do that in parallel.
Right.
And I can do my parts, get them done, and then they can say, oh, I found out I have to change this part or I need this other circuit in there, and I've just uploaded it. You can pull it in and make the changes. And we do that very often.
Which is really great. And I know here at Altium, R&D is working very hard to make sure that people can work concurrently, right? And building those subversion networks and even going beyond that, right? As we delve into Nexus and other products is to enable that, right? So you guys are seeing each other's work in real time.
Oftentimes, this is kind of a neat thing about that tool. We typically, the group I'm in is the new product development group. So we take the pie in the sky guys stuff and we turn it into a product. Then we have reliability engineers who have to design a test bed to test the product. So oftentimes when the schematic gets to 90%, they've got a copy of it and they're looking at it while we're designing it for
there's
the
concurrent engineering, isn't there?
Exactly.
So it really is a tool that enables that concurrent engineering.
It enables it.
So that's great.
So we're able to do that, and then the guys in production want to know what's going on with it, so they can pull down a copy and look at it. And then the next time we have a review meeting, they'll bring their thoughts to the meeting, and they can say, we like what you did over here, but we'd like to change this because it helps us be more efficient.
Right.
And we can run that back through and says, we need to do that. We listen to them.
Which is so great.
Yeah. Having that dynamic
real-time
communication
loop.
going on is really huge in being successful the first time.
Yeah, that's great. It's great to hear. Yeah. So,
but tact is used to push back.
Tact.
Yes. I used to.
Yeah, and I
used to joke. I used to joke with my boss. Did you ever see the movie The Money Pit?
Yes.
And they were going to fix the house, and the plumber shows up, and he goes, "How long is it going to take?" I said, 2 weeks. 2 weeks. We used to do that. It's like, well, it'll take 2 weeks. Most people can accept 2 weeks, but we've got a new tool now at work, Playbook. And it allows them to get all the stakeholders involved in helping us schedule the project. So the people who say, I'm going to have my test part of it ready at this time, and I'm going to have the board ready at this time, and I'm going to have my schematic ready at this time.
Right.
The managers can see the whole thing without having to go
Oh.
running around and bug everybody. Boom,
Right.
it's all right here. Now,
Yeah.
if there's a problem with the schedule,
Yeah.
update it so we know what's going on.
Yeah.
Tell us. And they get it. They see the impacts. They see when things are going to happen, and they can strategize and make plans on how they're going to pull something in or adjust something
Right.
to be successful.
That's great.
That's a
Kind of
neat
creates a
tool.
level of transparency, right? And
Yeah. So pushback is really more.
Well,
It's
that
more-
makes it sound like the manager's a bad guy. They've got a job to do, and they've got to
Well-
get a product to market in a timely way
Yeah.
at the right cost. So, I'm just saying is sometimes to your earlier comment, like the whips to the back,
Right. Well,
sometimes it feels like that, and
It
you're
does
like,
sometimes, yeah.
sometimes you have to stop and go, okay,
How can I communicate better?
yes, how can I communicate this in a way that makes me your ally here?
Exactly.
I
We're all on
want to
the
help
same
you
team.
win. We're all on the same team.
We're trying to win.
And me getting this done right the first time,
Yes.
I'm
You
going
can
to.
help me be successful
Right.
at doing it the first time.
That's right.
And you.
Right.
Because I want to get all the things that you need into the design.
Right.
That way you're happy with it and you can make it, and you're not gonna go, damn that Bill Brooks, why did he do this?
Right.
Right? I want to be.
Right.
I want to be
we
successful
love
like
the
the rest
finger
of them.
pointing, don't
Right.
we? Oh
They did it.
gosh, yeah.
I've seen it all.
I've lived through a lot of that.
Yep.
Well, Bill, this has been really good and really practical. I think where the rubber meets the road, and this part of the podcast, I sometimes like to call designers after hours.
Oh.
And I want to particularly focus on what you do after hours, because you are a very creative, kind of use both sides of your brain, but you have a very strong right brain. So can you tell us a little bit about what you do after hours when you're not designing boards? And
Gosh. I about, let's see, what was it, 2008? I went through a divorce, and I was trying to find something to do with my spare time, and I got introduced by another engineer at Daytron World Communications, where I used to work. And he was taking classes in sculpting. And he showed me a picture of a sculpture that he was creating, this head of his wife. And I had met his wife. She was wheelchair bound, and it was so neat to see the love, he's caring for
Right.
her, and she needs her to push her around and whatever. But he was making a sculpture of her, and I thought that was really cool. And the likeness was amazing. I thought, you really did a good job. I was really impressed with that. How in the world did you learn how to do that? He goes, I'm taking classes in Carlsbad. Bullshit. What? Nobody teaches that, right? I don't see classes for sculpture anywhere. Where do you find that? And he says, no, it's real. You should come check it out. So I made an appointment to go down and meet the teacher, and teacher introduced me to it, and I thought, this looks like too much fun. I gotta try it. And that started about a 6-year love affair with sculpting. And now I'm currently teaching it. So there's a place called the Green Art House in Fallbrook, and every Saturday I've got a class there, and I teach sculpting. And it's fun.
And we will share this link, by the way, because your mind will be blown. He doesn't just do a little hobby sculpting. Like, these are amazing sculptures he makes, and oh my goodness. And then I start prodding him about gee, I would love to take a painting class. Bill says, oh yeah, I do that too.
About 2 years ago, maybe almost 3. I was at a gallery where I had my bronze sculptures that I had made from the sculpting studio, and I was trying to see how they would be accepted in the public and so forth. So I had them in a gallery, and I met a guy there, Richard Sturgis, who's a teacher. He teaches how to paint. And so I got brave one day and I thought, I could do this. So I went down to Michael's and I went through the paint department and I found the primary colors and some paint brushes and a canvas, and I said, I can do this. And I just bought it and took it home, and I thought, I'll find a picture I like and I'm gonna try it. Well, about 3 hours later, I said, it's not bad. It doesn't look too bad. I bet if somebody taught me, I could do better. So I asked him, I says, I see you teaching people. Can I come? He said, sure, come on down. So that started me learning how to paint. And I've done about 8 or 9 paintings. One of them's a triptych. It's some cheetahs that's hanging in my mother's home behind her couch. And it's real pretty. And a lot of horses. I've done some things.
I know. I love horses. I owned a horse, and so I love your sculptures and your paintings of horses.
We used to have horses too, so I know.
You did?
Yeah. So I know the bond and the connection with the animals.
Yeah.
They're amazing.
So anyways, just for giggles, we will share Bill's amazing artwork there, because he does have a good after hours gift there. Will you please share with me I know you've shared with me some links and things. We'll make sure we put those up for our listeners that could glean more information from Bill. Bill's also taught PCB at our local college here, and he has mentored many people as well as being mentored throughout his career. So we will be sure.
I can blame that on Rick Hartley.
Rick Hartley, who we just had on the podcast today.
Yes, he was. He in fact, he cornered me. We were doing an interview right after the Top Gun at PCB West.
Okay.
And he said, Bill, you've got a lot of experience. Have you ever thought of mentoring? And I said, no, I never thought about it. To me, making boards was just a way to get a paycheck, right? Get paid, go home, buy food, take care of family, do all that stuff. And that seed planted made me seek out the IPC Designers Council. And I joined the local group in San Diego, eventually became part of the board. And then I joined the international group and actually became part of the executive committee and also the education committee. And I think I've got an emeritus status now with them. I mean, I've been with them a long time, and I've contributed as much as I could. In fact, they gave me an award once for contributing to the industry, so it was kind of fun.
So, we'll provide all the links we can. We thank you again for joining us, Bill. Thanks for joining us today in office.
Thanks.
And again, this has been Judy Warner with Altium's OnTrack podcast and Bill Brook with Nordson Asymtek. Thanks for listening. We'll see you next time. Until then, always stay on track.